Hey there, Algebra 2 students. Welcome back to Miss McGuire's classroom. Today we're going to be doing Unit 4, Lesson 8, Graphing Polynomial Functions, Part 2. As always, don't forget to put your first and last name, the period, and the date in the upper right-hand corner, so that way you get those free points when you turn in your notes, because your name, the date, and the period are all on the paper. Our objective today is I will graph and identify key features of higher degree polynomial functions algebraically. Mastery will be demonstrated by scoring at least 80% on today's homework. So what I did was I wrote out all of our steps for graphing polynomial functions. The exact same steps that we used in our lesson 7 notes, but instead of putting them on every single problem, I just put them in a handy dandy little table for us at the top of our notes. That way we can refer back to them as we need them. So remember, step 1, we always identify the end behavior first. Step 2, we find the x-intercepts and graph them. Step 3, we find the y-intercept and graph it. Step 4, we use a table of values to find points in between the x-intercepts to help us, further figure out how the sketch of this graph is going to look. So let's go ahead and dive right in to example 1. So for example 1, we are going to sketch the graph of f of x equals x cubed minus 2x squared. So the very first thing we want to do, step 1, is identify the end behavior. So our end behavior for this graph, our first term is x cubed. It's positive and it's an odd degree. So the first term is positive and it has an odd degree. That tells me that my end behavior will be down and up. So to the far left, I'm going to go down, and to the far right, I'm going to go up. All right, step 2, we want to find our x-intercepts. So I like to make sure my work is labeled, my steps are labeled, my answers are labeled. That way I know how to read my work if I need to go back over it. I highly recommend you organize your work similarly. So to find my x-intercepts, I always plug in 0 for y. Use y equals 0. So to find these x-intercepts, I'm going to do 0 equals x cubed minus 2x squared. Then I always want to look and see, can this be factored? Can I factor out a GCF? Well, x cubed and x squared have a GCF of x squared. So what if I factor out x squared from each term? That would leave me with x minus 2. And I know that's right because x squared times x is x cubed. X squared times negative 2 is negative 2x squared. Then, because it's done being factored, I'm going to set each factor equal to 0. So I'm going to have x squared equals 0, x minus 2 equals 0. So for x minus 2 equals 0, I'm going to add 2 to both sides. I get x equals 2. For x squared equals 0, well, what's squared is 0? We could square root both sides. So then x squared, the square and the square root cancel. The square root of 0 is just 0. When I square root something, I get 2 answers, plus or minus 0, but plus and minus 0 is just 0, which tells me that because this was x squared, this 0 happens twice. So x equals 0 with a multiplicity of 2, and then x equals 2. So my x-intercepts are 0, 0, and 2, 0. So why don't we go ahead and graph those? So let me get this graph labeled. Remember, you need dashes on every single line, and then every other line needs to be numbered so we know what your scale is. So on my x-axis, I'm going to count by, I guess I'll count by ones, that's fine. We could count by halves and just stretch it out a little bit, but this will be fine. And I'm going to wait to actually do my scale for my y-axis until I know like what my y-intercept is, what kind of y values I'm looking for here. So let's do negative 2. No, I just said I was going to wait to label that, and then I labeled it. All right, so let's graph 0, 0, and 2, 0. So there's my x-intercepts. Step 3 is to find your y-intercept. So step 3, y-intercept. Remember, whenever we find our y-intercept, we use x equals 0. So we're going to have y is equal to x cubed minus 2x squared. Y is equal to 0 cubed minus 2 times 0 squared. Well, that ends up with 0 minus 0, which is just 0. So our y-intercept is 0, 0, which also happened to be one of our x-intercepts, which is fine. That's totally allowed. So our y-intercept and our x-intercept are both at 0, 0. All right, step 4, we need to find some extra points. Well, we already know our end behavior, right? We know our end behavior is down and up. That means that from this x-intercept at 0, 0, my graph has to go down. And from this x-intercept at 2, 0, my graph has to increase. So we need to know what happens between these 2 points. To do that, we're going to just make a table with some x and y values. And we're just going to pick some x values. Well, the easiest x value to plug in here is 1. So let's just plug in 1 to our function and see what we get for y. So again, we're using y is equal to x cubed minus 2x squared. We're going to plug in 1. Y is equal to 1 cubed minus 2 times 1 squared. 1 cubed is 1. 1 squared is 1. Negative 2 times 1 is negative 2. 1 minus 2 is negative 1. So we have the point 1, negative 1. So now we see that for that point, 1, negative 1, right here, our graph goes down, hits that point, and then comes back up. So our graph does this. I don't like what I did there. Let me fix it. Our graph comes down to this point, and then back up to the x-intercept. So our graph does something like this. Remember, it's a sketch. So as long as your end behavior and the points in between the x-intercepts are good, we should be fine. All right. So there we go. We've graphed f of x equals x cubed minus 2x squared. All right, why don't you go ahead and get started on example 2 on your own. You're going to walk through each of the steps. I'm going to ask you questions through the Edpuzzle as you go, just to check and make sure that you're on the right track. So let's give it a shot. Step 1, identify the end behavior. So our leading term is positive. We have an even degree, so our end behavior is up and up. And remember, if you don't remember or have memorized the end behavior chart, look at our notes from lesson 7, and you'll be able to remind yourself the end behaviors based on positive, negative leading term, and then an even and odd degree. Step 2, now you need to find the x-intercepts. So go ahead and find the x-intercepts. I'm going to ask you for them in the Edpuzzle. You're going to press pause and then press play when you're ready to check your work. Good luck. So for the x-intercepts, I found x equals 0 with a multiplicity of 3 and x equals negative 1. So I'm going to plot 0, 0 and negative 1, 0. All right. So I also realized as I was labeling this graph that I forgot to label the x values on our graph from number 1. Make sure you got your y-axis labeled. Hopefully you're better than me and remember to do that. All right, so for number 2, moving on, we found our end behavior, our x-intercepts, now we need our y-intercept. Step 3, y-intercept. Remember, use x equals 0 this time and find that point. All right, so for your y-intercept, you should have gotten 0, 0, which was one of our x-intercepts, so we've actually already plotted that. Now it's time to find some extra points. So we already know our end behavior. We know to the far left, we're going up, to the far right, we're going up. So that means that to the far left, after the far left x-intercept, our graph is going to be increasing, as well as to the far right. So we need to find out what it does between these 2 points. So to do that, well, since this was 0 and this is negative 1, let's plug in the x value between those. So I'm going to plug in the x value of negative 1/2 or negative 0.5. So go ahead and plug in negative 0.5 into our function and see what you get for y. All right, so I got negative 0.0625 when I plugged in negative 1 1/2, negative 0.5. So that point is going to be literally just under the x-axis. So our graph looks like this when we're done between those x-intercepts. And then we need to label our y-axis, of course, because we want full credit for our graphs. And there we go. All right, so example 3 is kind of like the examples that we did on our notes from lesson 7. I just wanted to do them again, make sure we really understand what's going on. So we're going to follow the same steps, of course. So step 1, identify the end behavior. So my end behavior is going to be, so if I have a negative out in front of this function, after I multiply this whole thing out, that means my leading term is going to be a negative. Remember, we always factored out that negative if our first term was negative. So it's kind of like the same concept. So I know that it's negative. For the degree, I'm going to have x to the first here. So 1 plus 2 plus 7 is 10. So I have an even degree of 10. So it's negative with an even degree. My end behavior will be down and down. Number 2, for our x-intercepts. Now, the nice thing about this problem is that it was already factored for us. So I'm going to plug in 0 for y, of course. Then I'm going to take each factor and set them equal to 0. So negative 2x equals 0, 3x plus 1 equals 0, and x plus 7 equals 0. So my x-intercepts are, let's see, subtract 7 to both sides, x equals negative 7. Subtract 1 to both sides, 3x equals negative 1. So x equals negative 1/3. Divide both sides by negative 2. So x is equal to 0. So my x-intercepts are the points 0, 0, negative 1/3, 0, and negative 7, 0. Fun stuff. All right, let's get those graphed. Let's get our graph labeled. And then let's graph those points. So we're going to be at 0, 0. Negative 1/3 is like right after 0, 0. And then negative 7, 0. All right, now let's find our y-intercept. We use x equals 0. So y is equal to negative 2 times 0 times 3 times 0 plus 1 squared times 0 plus 7 to the 7th. Negative 2 times 0 is 0. 0 times 3 times 0 is 0 plus 1 is 1 squared. 0 plus 7 is 7 to the 7th. Now, it doesn't really matter what 1 squared and 7 to the 7th are because we're multiplying it by 0. And 0 times all of this is just 0. So our y-intercept is at 0, 0, which we've already graphed because it was also one of our x-intercepts. Now for the last step, we need to find some extra points. So let's see what we should use. Well, to be honest, between 0 and negative 1/3, we're just gonna like sketch it in to connect them. We already know our end behavior, so to the far left, we're going down. So after the far left x-intercept, we're headed down. And to the far right, we're also headed down. So let's find a couple points between negative 7 and negative 1/3. Let's do, let me think for a second. We should probably do like negative 5 and negative 3. Yeah, let's do that. Negative 5 and negative 3. Because then that'll give us a point around here and around here, which will give us a good idea what our graph is doing. So we're going to take our equation. I did not leave myself any room. y is equal to -2 times -5 times 3 times -5 plus 1 squared times -5 plus 7 to the 7th. So y is equal to -2 times -5 is 10. 3 times -5 is -15 plus 1 squared. -5 plus 7 is 2 to the 7th. So y is equal to 10 times 14 squared, -14 squared, times 2 to the 7th. Let's do this. So we're going to have 10 times -14 squared times 2 to the 7th. 250,880. That's fun. 250,880. And then let's plug in -3. So -2 times -3 is 6. 3 times -3 is -9. -3 plus 7 is 4. And then -9 plus 1 is 8. So we're going to have 6 times -8 squared times 4 to the 7th. So we're going to have 6 times -8 squared times 4 to the 7th. 620, wait, no. $6,291,456. I don't think that's right. I wonder if I made a mistake. All right, so I just double checked my work. I wanted to make sure that that number was not crazy. It's a huge number, but it should be right. I don't know. Let me know if I'm wrong, like y'all always do. So let's go ahead and start graphing for that. I'm going to erase this so it's away from my graph. So apparently this graph needs to get to 6 million. So that's fun. 3, 1, 2, 3. Okay, so let's just count by millions then. 1, 2, 3, 4, 5, 6, 7, 8. Like we did last week. So, and we'll just make a note that these are millions. All right, so let's plot -5 and then 250,000 is going to be under 1 million. And then -3 went all the way up to 6.2 million. So there we go. So our graph does something like this. Fun times. Those big numbers like throw you for a loop, huh? I had to like double check. Hopefully our work matches. All right, let's go for example 4. So sketch a graph of g of x equals x plus 2 to the 5th times x minus 4 cubed times x minus 8. So I actually want you to just do this whole problem on your own. You're going to find the end behavior, you're going to find the x-intercepts, you're going to find the y-intercept, you're going to find the extra points. Just go all out, get this whole problem done on your own. I believe in you. It's time for you to be able to walk through all 4 steps without prompting from me and just give it a shot. So you're going to press pause and then press play and get this thing graphed and then compare your graph to mine when you're done. Good luck. All right, let me show you all of my work and then we'll look at the graph. So for end behavior, I figured out it would be down and up. Our x-intercepts are at -2, 0, 4, 0, and 8, 0. We have a y-intercept at 0, 16,384. After I plotted my x-intercepts, I realized that I would need a point between like 0 and 4 and 4 and 8. So I plugged in 2 and 6, put them on my table. When I plugged in 2, I got 49,152. When I plugged in 6, I got -524,288. So on my y-axis, I counted by 50 1,000 for each one. So I have 100,000, so 50,000, 100,000, 150, 200,000, 250, 300,000, etc. And then same for the negatives. So then I plotted all my x-intercepts at -2, 4, and 8. I plotted my y-intercept, the point I found for 2, x equals 2, the point I found for x equals 6, and then I sketched in my graph. I knew that my end behavior was down, so from the far left, x-intercept I needed to go down, and from the far right, x-intercept I needed to go up. And that is my graph. Hopefully your graph turned out similar. All right, I'll see you guys back in class. There's no extra practice today. You're going to jump right into your homework. You're going to self-grade it like we have been doing, and then submit the graded version. Make sure you show all of your work so you can get all of the credit. I'll see you back in class. I hope you have a great day. Bye.